I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics, medicine,
nature,
or
Space. Time.
the brain,
Life. The universe.
This week, we go back in time to meet the Neolithic people, to find out how our ancestors changed the world and how archaeologists are digging up their secrets. I'm Georgia Mills, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
Each week on The Naked Scientist, we talk about the most exciting technologies and inventions of the day. Humans are managing to 3D print organs, blast rockets into the sun, and make robots who can play football. Some of those things are more vital than others, but all of our current techno know-how lies on the foundation of thousands of years of innovation. And arguably, the most important period of innovation in our history was the Neolithic. Neolithic literally means new stone. It was the final period of the Stone Age, beginning around 12,000 years ago. It brought with it some of the most important developments of our history: stone tools, control over fire, and the advancement of farming. So this week, rather than looking to the future, we're taking a trip through history to try and find out what the Neolithic have ever done for us. Professor S.K. Willerslev is a geneticist and an expert in human evolution.
Well, the Neolithic people seems to be a group of people who have invented agriculture coming from the Middle East and Near East, becoming farmers basically, and then they're moving up through Europe, bringing that new lifestyle with them.
Right, so they started in the Middle East, but then they spread across the world, bringing their ideas with them. And they weren't a separate species from us, though.
No. It's anatomically modern humans, basically. But of course, they have different genetic composition than the hunter-gatherers that are living in Europe at the time when they're entering. And this is why we genetically can observe their entrance into Europe.
How do we understand their movements from their genetics?
Well, it's because, as I say, they have a different ancestry from the hunter-gatherers. And therefore, when you sequence the genomes of ancient individuals, there you can see that some of them are completely different from the contemporary hunter-gatherers. And some are, you can say, mixtures between hunter-gatherers and these Neolithic farmers. So we can basically observe genetically how they are moving across Europe, approximately at what time they are entering the different parts of Europe, and to what extent they have genetically influenced the local hunter-gatherers.
They brought with them the advance of agriculture. What else made them special?
Well, I mean, they had both agriculture, they had domestic animals, and they were living in a different way. You can say that the society included more people than the typical hunter-gatherer groups, which were probably something like 20, 25 people most of the year. So these were, you can say, had real settlements. They also were non-mobile they didn't have a mobile lifestyle to the same extent as the hunter-gatherers. So they had a very different both way of life, but also a different food source, of course. I mean, the people in Europe that they were meeting were living from mainly hunting animals and fish and berries and nuts and things like that, what you would call a typical paleo diet, I guess, today. And these hunter-gatherers were basically living from something much more similar to present-day muesli. And therefore, we can see that this is a very drastic change in lifestyle. I mean, when we're going from hunter-gathering to farming, it's potentially the most severe change in lifestyle that we have undergone as humans. And we can see that the selection, even in the genome, in regard to things that are associated with diet. So, for example, these fat regions of the gene that are involved in transforming short-term fatty acids into long-term fatty acids. This is something we need, these long-chain fatty acids, for example, for our brain. And we're getting them directly through meat and fish. But if you are eating bread and carbohydrates, you need to basically change the short-chain fatty acids into long-chain fatty acids. And the fat regions of the genome is involved in that, and we can see there has been selection on those parts. So it's something that transition also affected us, not only in terms of admixture with new people, but it's also affecting us, you can say, biologically, if you want.
And did this starting to live in these sort of larger static settlements affect our susceptibility to disease as well?
Definitely. I mean, we don't know yet whether these agriculturalists brought diseases with them. We have some suspicion that this might be the case, but it's certainly, you can say, at least it's during that time or slightly after that time where we start seeing the first epidemics, like plague epidemics, for example. I mean, we see it already in the Bronze Age, which is the period just following the agricultural arrival into Europe. And so this change of lifestyle, of course, where you have more people together, is creating the background for epidemic outbreaks such as plague.
Why is it important to study them, to understand them?
In many ways, they are providing the fundament for the modern lifestyle, that we see today. Many people would argue, that the agricultural revolution in Europe is really creating the base for the creation of civilizations and our civilization today. Other people have argued, of course, that it's the worst thing that happened to humans because with the Neolithicization, there's also a lot of problems coming with this change in lifestyle. People have argued, that our suffering from diabetes and other lifestyle diseases is really a result of the agricultural revolution, and that we are, as a species, still trying to adapt to that change in lifestyle. But however you're looking at it, whether it was a positive or negative event, it's certainly an event that changed the way we are both living as humans. It's, you could say, an event that changed our ancestry in Europe, and it's an event that also changed and affected our biology.
That was Professor Eske Willerslev from Cambridge University and the University of Copenhagen. As Eske said, the Neolithic spread all around the world. But to get to know them intimately, I'm going to team up with a group of archaeologists and spend some time with just one settlement. An extremely exciting site that made the headlines, and of course the Naked Scientists, last year.
We have the earliest evidence of wine production in the world.
The expedition, which is aptly called the Grape Project, aims to find out about the origins of wine. And the sites in question are Shulaveri and Gadatrili in Georgia, which is a country squeezed between Turkey and Russia by the Black Sea, straddling the east and the west. And if you're an archaeologist, home to some of the most well-preserved Neolithic sites. I went along with the project to their dig site to find out more about the Neolithic, but to also find out how to be an archaeologist. After watching Indiana Jones, who hasn't wanted to don a bullwhip and fedora, dodge ancient traps while kicking the occasional Nazi butt? Well, it turns out there's almost no time for that, as a day in the life of an archaeologist is pretty full on. It's an early start at 5 a.m, so if you're a student or an excitable reporter, you woefully regret drinking all that cha-cha the night before and get on the bus to the dig site. You peel back the tarps protecting the dig site and start getting to work. And forget a hat and a whip, the tools of the trade are a little less dramatic.
Well, our most important tool is our trowel.
That's Natalia Hansiak, a PhD student at the University of Toronto. And, of course, her trowel.
This is Slayer. You are welcome to wield her today.
So this is your trowel's nickname, is Slayer?
It is, yeah. Yeah, we've been through some stuff together. She slayed some things for me. The second tool that we use quite a bit is a small pick, and that's just to break up the soil, especially when we're first starting to dig the hole. The other thing that is very important to us is a brush. It's important to be able to see what you're digging because you're moving dirt onto dirt, off of dirt, looking at dirt. So it's important to keep the old dirt off the new dirt and keep all your dirt separate. We follow what's called the probe and peel method. So what we do is we start in a small area of the square and bring it down until we find a change in the soil, some new architecture, something along those lines. So we're not digging blind across a 5 by 5 meter space, just maybe a 10 centimeter by 2 meter space. Once we find some of that information, we then extend that small hole we've made across the whole square.
Because soils build up over the millennia, each layer of soil represents a different point in time. So this probe and peel method excavates a bit by bit so you don't miss anything. But it's certainly not easy.
Oh, this hurts your legs.
A little bit, the ankles too, and the knees, and the back.
And for long periods, you don't find anything except the occasional rock.
The eternal, is it a rock? Is it an artifact question looms over us all.
or the odd creepy crawly.
Well, we'll
Watch
try
out, there's
anyways.
a big old ant on the brick.
Oh, that's fine.
Do they bite?
Maybe, but I'm bigger than...
But every now and then,
Oh, wow. Oh, wow. Look at that.
This one is really
Now, that is a huge one. Look at that. Beautiful.
you hit the jackpot, be it tool, bone or pot, and then you extract it.
Very carefully
And it's all tagged and bagged.
for its long trip through science.
And as well as the artifacts, in a site like this, you'd also keep a lookout for big bits of charcoal.
Yeah, so these are all some sort of carbonized wood, which is awesome because it tells us that there was definitely burning here. But it also is what we hinge our carbon dates on, which is how we put the site in an absolute time. So a lot of the artifacts, just due to their characteristics, will tell us that they're Neolithic, based on where they are in the ground, but also how they relate to other sites in the area. But our really big question with the excavations here at Gattatrilli and over at Shulaveri is, where does this actually fit on like a real time scale? How far back are we talking about when we say origins of wine, people using hides, possibly domesticated dogs? Like, what does that actually mean?
And the buckets and buckets of soil that are removed are sampled and sifted to collect any small pieces that may have escaped you. All the while, as you go, you record, draw and photograph everything you can.
Every single time we move, even just like a speck of dirt, we are technically destroying something that has sat in place for anywhere from 10,000 years to a couple months, but we are very much disturbing everything that we touch. So it's very, very important for us to make sure that we maintain meticulous notes, because as soon as it's gone, it's completely gone.
At the end of the day, they even take a photo of the whole site using a drone. Apparently in pre-drone days, they tried everything from kites to selfie sticks to get this bit done. And after many hard hours of graft, it's back to HQ. There, the students start drawing, labelling and sorting their finds, ready to go into the lab for analysis, all under the watchful eye of project mascot Lulu. Others go out on a survey, walking over wilderness, looking for anything that might indicate an interesting place to dig in future, all the while avoiding the local snakes, which I'm told are liable to coil up and spring at you, like terrifying slinkies. I don't know whether to believe this. And once again, finding genuine artefacts is pretty rare. I uncovered some Soviet metal, one livid scorpion, and you guessed it, more rocks.
What we charitably call an interesting rock.
We call it in Turkish a güzel taş. A pretty stone, but just a stone.
Why didn't they make their tools more obvious and write their names on them and stuff?
Then it's back to base, time for a quick dinner and off to bed, ready for another 5 a.m. start, trying to get a good night's kip through the thunderstorms that are loud enough to shake your bones and the odd earthquake. So, apart from the snakes, only a passing resemblance to Indiana Jones.
That movie really set up false expectations for me.
You just can't trust Hollywood. That was Natalia Hanziak with a day in the life of an archaeologist. But what about the people whose lives they're digging up? The artefacts all tell stories, but the first thing you notice on the dig site are the remnants of their houses. Stephen Batrick is an archaeologist with the Great Project from the University of Toronto, and he's been digging at Shulaveri for a number of years and gave me the tour.
This is your standard Shulaveri Shomu village. So what you have is a series of circular structures, varying in size from 1 meter to, well, our largest one is close to 7 meters. They're clustered together. Sometimes you have buildings that are clustered in a figure-8 pattern, like these two large ones over here, so that you have them in the figure-8 pattern, or you'll have them nearby, and you will also see sort of circular walls that will join them as well. And they'll form sort of small clusters, almost like a household area where you have a couple of structures and an enclosed courtyard, if you will. That's sort of the general pattern that you see, and what you're looking at too in these squares, you can see that some of them are different levels. You're looking at different phases of construction. So what the lowest one would have been built first, and then later they build that on and then add on over time. So these families, if you will, would have been expanding over time.
And what were the houses themselves made out of? Walter Mancini is an archaeologist from Italy, also working with the project.
What we're doing now is taking a sample of a mud brick from the lower level of the site, so that this French mud brick expert can analyze it and tell us, something about them.
Right, and
I don't know.
mud brick is what they've been building. These the people who lived here were building
Yes.
everything out of. It looks like.
Yeah, they are clay mud brick, and they're sun-baked, as you can see. And the inclusions here inside the clay. This is definitely mud brick.
Mhm.
And all these holes, little holes that you can see here, are pretty much decayed organic material, like plants, which are found in the clay, and mixed together with the clay to compact pretty much the mud brick and make it more solid.
As well as plant material like wheat, the mud bricks were mixed together with poo and occasionally bone to make them stronger. It may not sound like the most enticing thing to build your house from, but the Neolithic knew what they were doing. These things could really last.
What's this giant? I've been wondering about this. It looks like an anthill, just slightly taller than me behind me. What is this?
This is one of the earliest structure that we have on the site, and it's one of the most well preserved. And what we did last year was to build a sort of cover with clay, but unfortunately it collapsed at the beginning of this year. So maybe we didn't get the right amount of clay or the right proportions. Mud brick was.
So the 10,000-year-old structure stood up, and the one you guys made fell down in a year.
They're better than us, that's for sure.
So newfound respect for the Neolithic.
For sure, no.
And I've got to say, I've been on the lookout for good Indiana Jones hats, and I haven't seen any yet, but yours is closest, so I've got to congratulate you on your hat game.
Oh, thank you so much, Noel. I'm Italian, so fashion is first concern.
Fashion icon Walter Mancini there. So they had these sturdy houses, but what was life actually like in a Neolithic village? Back to Steve.
Well, it would have been pretty tight clustered houses. So people would have been pretty much on top of each other. And as you can see, the houses aren't that large. They would not be doing a lot of their activities inside. They would have been doing them outside, especially in those courtyard areas around the houses. You would have had agricultural fields that would have been immediately around. And it also seems that they would have had vineyards around here as well. Some of the work that the Georgians have done, we have an excellent palynologist who works at the Georgian National Museum, where she's been collecting soil samples from either outside in the courtyards or inside the buildings, and she's been able to actually find grape pollen, vine pollen essentially. And she's also done other studies with modern vineyards and realized that the grape pollen doesn't go very far. So for it to be in these houses means the vineyards had to be either close or they're collecting the flowers or whatnot and bringing them nearby. So there probably were vineyards within the immediate vicinity. And then couple that with the motif of the grapes, this sort of led to the idea that they were probably drinking wine in here as well. So it would have been a simple agricultural village, growing wheat, barley, other legumes, but also undertaking horticultural practices.
This evidence for viticulture and wine is what makes these sites so important. Last year, they found a pot with a residue containing a combination of acids, which indicates wine, which had been dated to around 8,000 years ago, which pushed the date back for the earliest winemaking by around 1,000 years. And that's not all.
Viticulture, growing vineyards would have been the main things. And then also, it now seems, based on some of the new evidence that we have, apiculture as well. Basically, they would have been caring for bees, if you will.
Oh, wow.
This is one of the things that we're presently working on, is we also have the earliest evidence for honey.
What form does that take?
It's the same person, our pollen specialist. She was looking at a sample it comes from the site of Schulaveri, where we're also working. Basically, it's a trash pit from a hearth. And so somebody had been cooking and then cleaning out all the ash and everything like that. And so she was looking at it, and the sample that she had this incredible, this clustering of pollen of a very diverse variety of basically meadow plants and also arboreal flowers. According to pollen specialists, this is the signature of honey, because I should also add that there were also insect legs, like honey legs, that were still caught in this as well. You will not have such a diverse collection of pollen like that if it's an anthropogenic thing, because we can't collect that, or we won't normally collect that diverse of pollen or flowers, if you will. But bees are going from flower to flower all across the place within, I think it's a 7-kilometer range. They can collect that great variety, and that's what's represented. That's the signature, if you will, of honey, of having that great variety of pollen.
Right, so they didn't have much space to move around in, but they had wine and they had honey, so life might have been quite good.
Wouldn't have been that bad, I imagine.
Is the site one singular sort of settlement over time, or is it several?
Well, this is actually one of the interesting things that we have started to understand just really sort of this year. What you do have is if you look across the landscape, you have our mound. You can see another mound over there. That is the site of Imiris Gora. It was also excavated in the 1960s. Then off over there, 2 kilometers away, is the eponymous site of Shulaveri Gora, which had been excavated in the 1960s by the Georgians. And what you seem to be looking at is a cluster of sites, but they're all occupied at different time periods over the sort of 1,000 years of the Shulaveri Shomo culture.
This seemed to be a total mystery. The Neolithic people were building these perfectly good mud brick houses, staying for a couple of 100 years, and then suddenly taking off and leaving, forming a new settlement a few kilometres away. But why? Well, the answer may lie with a key bit of information we know about farming. Howard Griffiths is Professor of Plant Ecology at the University of Cambridge.
So when farmers crop land for too long, you tend to get that one crop uses similar amounts of nutrients year on year. So you tend to get progressive impoverishment of the soil. And also you tend to get build-up of pathogens. So the two things tend to mean that progressively yields tend to decline with time.
Right, so if I'm having a field of wheat that I wanted to run through year after year, the wheat would eat the same nutrients again and again out of this soil. It wouldn't have any way of replenishing them. And the same diseases that, like the wheat as well, would be building up year on year.
Yeah, and it's exactly what we see in East Anglia here, where we have a take-all, which progressively reduces wheat yields, and that's why we have to rotate crops.
So what's crop rotation?
Well, basically, it means that under the current example, you grow a single crop perhaps for 2 years at most before switching to another crop to allow the soil to recover.
How does the soil get its nutrients back?
Well, 2 ways really. One is that the increased weathering brings in more nutrients from the bedrock, and that is of course helped by the roots, which actually help to digest some of the rocks with the acid waters going down through. Otherwise, through fertilizers that come in, some naturally as a result of lightning, bringing in nitrogen, others of course through manures, and that's where progressively early man probably would have learnt fairly quickly that some form of manuring would aid crop productivity.
And so if you replaced wheat with something else, then also the bacteria or whatever it was that was feasting on the wheat would have nothing to eat and hopefully disappear as well.
Yes, that's the general idea. Yeah, so it just gives a break, and so then the land is healthier and more nutrient rich, ready for the crop when you replant it.
How long does it take for a soil to recover between wheats?
Well, as I say, currently I think it's in the region of between about a year or so, or a year or two, following intensive cropping. Although I believe in the east of England there are some farmers that are able to get through this kind of rather impoverished time and can grow wheat continuously, but it tends to result in lower yields.
And this is exactly why the archaeologists think the settlements were moving around the landscape. They had only just started to farm, so hadn't hit upon this idea of crop rotation, but they were finding their yields were less and less each year. So, after using up all of the land around a settlement, it was time to move on. But what kind of things were they farming? Back to Howard.
Okay, well, the earlier evidence suggests that we started to select early wheat varieties. There's one variety called einkorn, which, as it sounds like, it just has a single grain in its ear.
Wheat's quite surprising because if you look at wheat, and I guess you don't realise you can turn it into tasty, tasty bread and pasta, it doesn't look sort of immediately useful. I'd much rather something I could eat straight away.
Well, like all of these things, one wonders, how much of this was found by accident in conjunction with leaving grains near the fire and so on. But we do know that the early Neolithic man had breads and had found ways of grinding grains to make flour. So it rapidly became adopted, I think, as a staple diet. We have wheat and barley were early domesticates, but also things like poppy and flax and some legumes as well, so lentils and vetches and so on. Those were the earliest crops.
How have those crops themselves been changed by our repeated farming of them? Would they be recognisable, I suppose?
Well, it's an interesting question to the extent as whether the seeds have actually increased. What we certainly have managed to do is select grains with increasing yields, but at the same time, we've been able to build on a number of chance hybridizations whereby two grasses accidentally merged their genetic basis, and that led to this hybrid effect with increased yield, and that ultimately has led us to with the characteristic wheat ear that we now recognise. Whereas if you saw one of those early wheats, you'd scarcely recognise it as a crop that we'd recognise as wheat today.
Right. And in terms of the farming itself, how has that developed in the last 10,000 years? I imagine quite a bit.
Well, indeed. I mean, there's a lot of debate in the UK about the extent that the forests were initially cleared in what's the Stone Age. But I think in the UK, certainly, we think that the chalk was cleared first, which would have been the uplands because of it's the lighter soil. So it's easier to plough with early sort of stick ploughs and so on. And that would have been cultivated initially. The argument goes that it was only later, about 1,000 years BC or so, that the iron shod plough came in from Belgium and so on, and that then led to the heavier clays being tilled.
What is tilling?
Well, basically, it's a question of having cleared the basic forest. It's then a question of creating a seed bed, because what growing crops is all about is creating a monoculture. And in fact, funnily enough, some of the earliest Neolithic sites have seeds of weeds, very characteristic as well. So sort of speedwells that we characteristically find in our flower beds and so on today. Presumably they were weeds that were growing amongst the crops, the barley and wheat, that were being cultivated by those earliest farmers.
Howard Griffiths there from the University of Cambridge.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
This week on The Naked Scientist, you're with me, Georgia Mills, and I'm probing the past and finding out what the Neolithic have ever done for us. We've built up a stronger picture of life a few thousand years ago. They were living in circular houses made largely from mud with a little hint of poo and bone, and were farming the surrounding lands, enjoying bread, honey and wine for dinner. But to find out more, it's time to look more closely at some of the artefacts the team has been finding. And there was one that caused considerable excitement in the square Natalia Hanziak was supervising. And apologies, archaeologists have potty mouths.
Oh, wow. Look at that. Look at that. Beautiful.
So even to my very untrained eye, I can tell this is something.
Exactly, it's thingliness, really. So what we're looking at here is a large obsidian blade. An obsidian is a volcanic flow that dried very, very quickly, so it has the appearance of glass, essentially. So these are essentially used as blades, as knives, as sickles, and we pull out quite a few of these from the square. This is our second or third one from this hole right now. And as you can see, the edges look a little bit serrated. They've been reworked, telling us that this blade was probably used quite a bit. And the way that there is this divot in the edge also tells us that it was most likely used at some point before it was buried next to this wall.
These obsidian blades turned up quite a lot, with various different markings indicating what they might have been used for. And perhaps the best way to understand how the Neolithic made and used these is to try it for yourself. Sean Doyle is the project's resident napper, which is not, as I initially assumed, because he slept too much.
Knapping, K-N-A-P-P-I-N-G, is the general term used for the production of chipped stone tools. But generally, it's the tools that are made with silicious material.
Silicious?
It is a very silicious rock, actually. Obsidian has a very high silica content. Silicious stone is a stone where its main component is silica.
Right. And obsidian is the thing that earlier in the dig we found lots of tools made of obsidian, and you've got a massive rock of it here, and it's dark and black and shiny and very beautiful. And I also know this is the thing that in Game of Thrones they're very excited about. They call it dragon glass. So this is, to me, quite a mystical object. But what actually is it?
First of all, I'm a big Game of Thrones fan, so I love me some dragon glass. And if I can kill a White Walker one day, I totally would. In our world, obsidian is a stone that's formed in volcanic eruptions. You need a lava that has a really low viscosity, which means it's very fluid and liquid, and it supercools very quickly, so quickly that the elements inside don't have time to crystallize. So you end up with a very homogeneous natural glass material. The crystallization process kind of ruins its predictability. So the more glass-like it is, the more predictable it is, and the more easily you can flake it into the tools that you want. Other siliceous stones are flint and various types of chert, like chalcedony or opal, or some quartz.
Take me through napping then. How would I go about turning this big block into a nice little, I don't know, a knife?
You just stare at your stone a lot until it speaks to you.
Oh, wow. That's so very scientific then.
Yeah, that's the easy way to put it. But really, it depends on what you're trying to do with the stone. If you're just trying to take a flake that you can use to cut something with, you're just looking for an angle that's under 90 degrees. This one here is about 70. And you're just looking for a flat, strong platform that you can hit with the stone that will withstand the strike and allow the shock wave to travel through the piece. Kind of like this.
Eureka. Oh, that's a really nice one.
So that's a nice thick flake. You know, it's such a versatile material that you can pretty much shape it into anything you want once you know what you're doing.
Once you know what you're doing being the operative phrase here. That didn't stop me from demanding a go, and I don't know why you'd have large chunks of obsidian lying around your house, but please don't try this at home. I found out it's very easy to cut yourself.
I have a few scars from my learning days. But every scar is a lesson. That's what I always say.
So the rock speaks to me, yeah?
There you go.
Oh no, it didn't do a nice flake like yours. I just cut off the end.
Yeah, well, it exploded a little bit, but that's part of the learning process.
Okay.
You're gonna...
What did I do wrong?
A couple things.
So we mentioned Game of Thrones earlier. Could you make a sword out of this stuff? Would it work?
Well, I could make a sword, but it probably wouldn't be the most practical thing. It would probably break in half the first time you tried to hit something with it.
Brittle, it may be, but what it lacks in sturdiness, it makes up for in its edge, which I would say was razor sharp, but really it makes a razor look like a crayon.
Yeah, so obsidian is so sharp, a sharp edge can be something like 2 nanometers in thickness or something like that. So it gets so thin that you can cut between blood cells. Actually, obsidian is still used in some modern surgeries for that reason, but also because you can sterilize it really easily. It doesn't have the same pores as surgical or modern steel does, so you can sterilize it really easily.
Do we think the Neolithic people were using it for surgery?
You know what? They probably might have been. They used it for all sorts of different things, including scarification, bloodletting, maybe tattooing even. Yeah, it's a very versatile material. They even made mirrors with it. The first mirrors in the world were made from obsidian.
Wow.
You'll be pleased to know none of the team used it to do any bloodletting, but one Georgian archaeologist, Dima, did actually manage to shave his beard with a blade. Again, please don't try this at home. But obsidian, as well as giving insights into how the Neolithic lived, can also tell us a bit about their movements.
Each obsidian source is unique in its chemical signature, actually. That's why it's used very effectively in sourcing, so we can use various lab instruments like X-ray diffraction and others to identify its trace elements so that you can match artifacts in the archaeological record to the obsidian source that it came from.
Right, so if people were trading with this, you'd know how far it had moved.
That's right, yeah. And because it's such a homogeneous material, it's much easier to do that than with, say, flint or chert. So you can tell exactly how far material was traveling in the past.
All hail obsidian then.
All hail obsidian. It's my favorite thing in the world.
Me too, now, I've decided.
Perfect.
Sean Doyle there, a napper, that's with a K, and a dragon glass wielder. So apart from these stone tools, or lithics, an important group of evidence are the remains of animals.
Hi, I'm Steve Rhodes. I'm the project zoo archaeologist for GRAPE.
And what is a zoo archaeologist?
I study animal bones and essentially, human subsistence based on that.
Awesome. So we've got we're in the lab now. It's lots of boxes of various things, and there's a lot of bones. So what kind of things have people been finding?
Well, predominantly in terms of food animals, there are a lot of caprines, mostly sheep, a few goats, a lot of pigs, a lot of cows, and then we also have wild versions as well as domesticated. So, we have domesticated sheep and goat, but it looks like we have some wild, like I found a very large horn core of what looks like a wild goat. And we also seem to have wild aurochs, which are wild oxen, the progenitors of domestic cattle, very much larger, and even possibly bison, which were native here many years ago. Some of the other interesting things, we have very large catfish. The Wells catfish is the common name, and they can get up to 2 or 3 meters long. And we have these bead objects here that were made from them that we're kind of curious about whether they were, decorative beads or possibly ear spools, or it's even been suggested they might have been spindle whorls for making fibers from wool or flax.
Oh, right. So it's kind of like a little bone donut, a tiny thing.
Yeah.
This is from a catfish.
Yeah, that's our best guess right now is catfish. It looks the most like that.
Right, so these guys were having a lot of animals to eat, and animals like the catfish, which maybe have been used in some kind of art or decoration. And then what else were they using animals for?
A huge amount of their technology, like their toolkit, was made from animal bone. And it's more so than in other parts of the Near East that I've worked, like in the Levant, where they have flint and they make a lot of tools out of flint. But here in eastern Georgia, there's almost no flint, and it's all obsidian, which is great for making some things, but it's not great for others because it's so fragile. So making a lot of tools out of it is problematic. For example, like we don't see any obsidian arrowheads. And, what I was thinking was that, maybe it's because when they hit the animal, they shatter inside it and fill your potential meal with lots of shards of tiny little glass. So the people probably figured that out really quickly. And what they do have are bone arrowheads, which are, quite uncommon in other places, but seem to be typical here. They seem to have been doing a lot of hide processing. So we have a huge number of awls, like piercing tools, that were made. They seem to have had a real consistent technique. So they have this really standardized, like, hide production industry, it looks like, throughout this whole culture that's quite interesting.
What were hides have been used for?
Predominantly clothing, I would assume, at this point, because it doesn't seem like they were doing any weaving, because we don't have really much evidence of that, and this would be very early for that. Probably using it for containers a lot, for carrying water and things like that, or, just general transportation of goods.
Could a hide survive that long? Could we ever uncover one?
Theoretically, in this environment, it's not likely. They have been found in places like bog deposits in Northern Europe, like Denmark, Ireland, places like that, or mummified, in places like Egypt or, high altitude sites in South America, places like that. But that's a very different environment than what we have, so it's highly unlikely we're ever going to find that here.
Not content to merely look at these bones, at the GRAPE project, they really wanted to get inside the minds of the Neolithic.
Okay, so then once you have the skin cut,
you like start tearing at it?
yeah, then you'll have to go.
There's a table covered in tiny sheep legs. There's a lot of students covered in blood. What
I wouldn't say covered in blood.
What on earth is going on?
We are replicating some of the bone tools that we're finding at the sites of Gadishvili and Shulaveris that we're excavating. You know, as part of the learning process, we're trying to learn how Neolithic people made their tools.
Right, and so you're using an obsidian blade to do what exactly?
The sheep legs came with the skin on, so first we have to remove the skin and the viscera, and then we have to disarticulate the metapodials from the phalanges, from the toes, because we're not using the toes, we're just using this part here. And then after we've done this, we're going to start breaking the bones, because we have to break these bones in half in order to replicate the tools here. So we're going to be, after we've got all the viscera off, we're going to be scoring them with a stone tool to guide the fracture when we break it, and then breaking them open with stones with like a hammer and anvil technique, and then finishing shaping them with other obsidian blades.
Right. Gory work, though.
I guess in one sense, but you know, if you're a Neolithic person, this would be nothing to you because you're used to living in the natural world. There were no butcher shops, you know, no restaurants. You did everything yourself.
Steve Rhodes there with some gruesome experimental archaeology. And while we're using the present to understand the past, I wanted to find out more about the discovery that made this site famous: winemaking. Because winemaking in Georgia is quite unusual, which may be a tradition they've kept from the very start. Alexander Chaidze is the managing director at KTW Group, which is one of Georgia's largest winemaking companies.
So we are an interesting country in terms of winemaking, because not only we do wine by traditional way of European way, but we also do our own traditional way, which is making wine in qvevris, which are clay vessels, huge ones, starting from maybe from 5 liters going up to a couple of thousand liters. We handpick the grapes, and after handpicking our grapes, we transfer it to our Maranis, where we have qvevris.
What's a Maroni?
Marani is a wine cellar in Georgia, a very widespread and national treasure word for us.
Marani, not Moroni.
Marani, not Moroni.
And do you have a Marani here?
Yes, I can walk you through.
Can we have a look?
Yeah, sure.
Fantastic.
Let's go.
Yeah, it's a beautiful building, massive church appearance. Wow, and now it's just opened up into this massive cellar full of wine bottles. It's a lot of wine you got here. What are these traps in the ground? They look like designed for people to fall down.
Yeah, those traps, we call them qvevris.
Oh, these are qvevris?
Yes, they are.
I'm going to stick my head in one. Oh my gosh, they're huge. Some excellent reverb in there. So you can probably tell from the sound just how big these are. And they are being kept underground for you to pour. I guess you put all the grapes in there and then seal it up.
Yep.
And so putting in wine in a qvevri, that's quite a different method to the rest of the world. So what impact does that have on a flavour?
It gives us stronger flavor than regular method of making wine, but qvevri is so different that I've never heard an instance when somebody tried qvevri and says, "Oh, that reminds me of something," because it's just so different. It gives its clay-like flavor, which is weird because we don't eat clay. But we have smelled it, we have experienced it, and there is a saying that we use in Georgia that clay makes wine better.
And almost as important as the wine-making traditions are the wine-drinking traditions.
Our supra, which is a feast, is a very interesting phenomenon. It's led by a guy named Tamada, who people choose before the feast.
So the tamada is someone who sort of leads the table.
Yeah, it leads the table by saying the toasts. When he says a toast, everybody has to say that toast. Maybe they can just say kaumarjos, which means cheers, but they can also add something. And usually when we drink, Tamada says something, and then all of us just say something about that toast. It's not only a drinking process, it process goes into communication, and you become close to each other after Georgian feast because you open up about many things and you talk about different stuff. It's not like just cheers, cheers, cheers and drink. And sometimes we have a thing called different, when we introduce some weird stuff to drink out of. It can sometimes be a huge clay jar or a vase or I don't know, some people drink out of a guitar as well or a shoe sometimes, but we don't do that kind of stuff. Mostly just something drinkable, like vase or huge glass, or to like add some kind of new flavor to the feast.
A new flavor, especially it's from a shoe.
Yeah, I don't like drinking from shoe.
Alexander Chaidze on Georgian drinking traditions there. So while the rest of us are less likely to drink it from a shoe, wine is incredibly popular across the world. But why really does it matter where and when we invented it? Why should we spend time and money digging up the past like this? Natalia Hanziak argues it tells us a lot about ourselves today.
Yeah, absolutely. Especially as you get more into asking questions of the past, you realize that you're really asking the questions that are important to us today. So the questions that we're asking might not even be relevant to people who lived 10,000 years ago, might not be something they think about, but the fact that it's something that we're thinking about today tells us a lot about what it is to be a person in the 21st century. So archaeology is fundamentally figuring out where humans came from and why we are the way we are today. So the materials that we look at, especially things like ceramics and plaster, we're investigating the first times humans made synthetic material, and synthetic material is a big part of our existence today. But furthermore, things like ceramic and like obsidian are still used as components in tools we use today, which is very cool.
When you're looking at things from, thousands of years ago, do you feel a kind of connection with the past?
Absolutely. Pulling something out of the ground that hasn't been touched in 10,000 years gives you a really close and intimate connection with the last person who touched it. You might not know who that person is, but it's a kind of connection through time and a little bit through space between yourself and essentially people who came before that made us who we are today.
And I've been here for just under a week, and so I haven't been getting up as early as you guys, for sort of 5 a.m. starts, back-breaking labour. What keeps you doing it? Because it's not easy, is it?
No, it's not an easy pursuit, but it's one that is incredibly rewarding. And part of it is that we work with people to get the work done. So you're forging human connections with people who you wouldn't necessarily work with daily. We are very, very lucky to work with incredible Georgian students, for instance. But also the experience of pulling something out of the ground and really revealing parts of a puzzle that you might or might not be able to put together in a coherent way is sort of like catnip. It'll just keep you going and keep you coming back for more.
Kind of like gambling.
A little bit like gambling.
Natalia Hanziak there. So how different really are we from our Neolithic ancestors? Back to Cambridge University's S.K. Willesleb.
There has been some evidence suggesting the hunter-gatherers that originally came into Europe, their appearance was quite different from today. I mean, they had much darker skin, they had blue or gray eyes, so they would have looked different from present-day Europeans. They would have language, but it would have been the hunter-gatherer language was most likely be very different from the language we are speaking today, because the Indo-European languages are first really coming into Europe during early Bronze Age with the Yamnaya expansion.
They have all these, you say they brought in all these innovations, but we know these days, we know about farming, we have all these sort of scientific reasoning behind us, but they wouldn't have known any of this. So how did they make so many innovations?
What made the farmers so successful is that for some reason, they must have had more children that survived, basically. I mean, so the population growth of the farmers seems to have been larger than among the hunter-gatherers. And it's kind of ironic in the sense that if you look at the health state of the farmers, it actually looks like the health state is poorer among the farmers than it is among the hunter-gatherers. So you can say in some ways, it was probably a less it was a less good life, if you want. I mean, that's how it looks, at least from the skeletons. I mean, they have teeth problems. They are fairly small. Their backs are kind of affected, by the line of lifestyle. Their nutrient stage is not as good as the hunter-gatherers, but still they seem to be, you can say, in terms of numbers, more successful than the hunter-gatherers.
The innovations they made, like, for example, that if you leave grapes out for a while, it makes wine. Would this have been intentional or accidental, do you think?
Well, it's a good question. I mean, it's not very clear exactly how the domestication happened. I mean, there's different theories on this. I mean, some believe it's kind of a very gradual thing, where you start nursing a little bit some wild crops and turning them into domestics over a long period, and it's something that happens fairly slowly. Others have argued that it's much more focused, and I don't think that's really resolved. But of course, when they're getting into Europe, they, to some extent, master this new way of life, at least to an extent where you can say it's successful, and they make possible the spread of that lifestyle.
A lifestyle we have to thank for modern life today, the good and the bad. To put it broadly, if anyone were to ask, what have the Neolithic ever done for us? Just take a look around. Thank you to Eske Willerslev from Cambridge University, and to all of the guests this week: Alexander Chaidze, Natalia Hanziak, Sean Doyle, Steve Rhodes, Stephen Batrick and Howard Griffiths. And also a huge thank you to Andrew Graham and the rest of the great project. Do join us next week for a look at the invisible substances that make the world go round. From digesting our food to running our cars, we're taking a look at catalysts. The Naked Scientist comes to you from Cambridge University. It's supported by Rolls-Royce and the STFC. I'm Georgia Mills, and thank you very much for listening. Goodbye.